This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're going to graph y equals -2 sine of x over 3 plus 1. We're going to state the domain, the range, and the period, as well as accurately sketch the graph, making sure we label the axes and state the 5 key points, which are the ordered pairs. All right, so we're going to have to state the domain, right? And then we're going to have to do the range, which we can call R, and the period. Okay, now this is a sine function, and there's no values for which the sine is not defined, so the domain is all real numbers. That's always true for the sine and the cosine. Now the range is a little bit trickier. I actually think it's easier to graph it and then look at the picture to determine the range. So let's see, how would we even begin to graph this? We would need to know the period, right? So let's figure out the period. So notice the coefficient of x, that's really like 1/3 times x. So the period for pi is for sine is 2 pi. So remember, you do 2 pi divided by the period. Divided by that coefficient. So that's 2 pi divided by 1/3, which is 2 pi times 3. So the period is going to be 6 pi. All right, so if I know it starts here at 0, 0, for instance, and it will because there is no phase shift, because in the parentheses there's no plus or minus sign. So I know that it goes from 0 to 6 pi. So this, of course, would be 3 pi. Remember, we go ahead and mark those 4 places. Okay. Another thing that you might notice is that we have a minus sign. So normally the sine function starts at 0, 0 and goes up. This one is going to go down first. And even though I didn't ask you to state the amplitude, it's going to be 2 because it's the absolute value of this coefficient of -2. But this plus 1 means the whole graph is also shifted up. So I didn't ask for the phase shift. There was none, by the way. And I didn't ask for the vertical shift, but the whole graph actually gets shifted up one space. So there's 2 ways to do this problem. One is by thinking about what's going on with the graph. It's all shifted up one place. So instead of at 0, 0, it's going to start up here at 0, 1. And normally the graph would go up, then back down to 0, and then down and back up again. But in this case, this -2 means it's going down first. But instead of going just over 1 and down 1, it's going down 2 spaces. So we should get an order pair down here. Sorry. And then it's going to come back up through here. So this method of doing it is thinking about what's going on, sort of doing some translations here, and we get this graph. And then by looking at the graph, you could determine the range. It's going between -1 up to 3. But notice I did this by not plugging in any ordered pairs at all for the sine. So I'm going to do this a different way as well. But right now, let's see what ordered pairs these are, and we'll see if that's really true. This is the ordered pair 0, 1, right? This is the ordered pair, well, if this is 3 pi, this is 3 pi over 2, right? So we can think of all of these in terms of 2 in the denominator. So this would be 3 pi over 2. This would be 6 pi over 2, which of course is the same thing as 3 pi. This would be 9 pi over 2. And of course 12 pi over 2 is the same as 6 pi. So if you wanted to see them all with a common denominator, that's what it would look like. But in any case, this ordered pair down here, I'm going to list my ordered pairs down here because there isn't a lot of room on that graph. So I have 0, 1, right? I have 3 pi over 2 negative 1. I've got 6 pi over 2, 1. Now, 6 pi over 2 could just be written as 3 pi, right? And then we have 9 pi over 2 up at 3. And we have 6 pi 1. So it's a good idea to see if these really would check in this original equation. So let's do that, and then I'll show you a different way of graphing this by first listing the ordered pairs and then going over here and graphing it. So here's how we could do just a little check. Let's just plug in one of these ordered pairs for x and y and make sure it's true. So I'm going to just do a little check here for one of the ordered pairs. So let's say I'm going to do it for this one right here. So if I put in 3 pi over 2 for x and I put in negative 1 for y, that would give you negative 1 on the left-hand side. And here we have negative 2 times the sine of, well, x over 3 is 1/3 times x. And what am I putting in for x? 3 pi over 2. And then we have plus 1. And let's just actually do the computation. Let's see, the 3's would cancel, so I'd have the sine of pi over 2 plus 1. Now the sine of pi over 2, that's up at 90 degrees. So remember, if you haven't memorized it, it's the y value up here. So that's going to be 1. And then negative 2 plus 1 is negative 1. So certainly this ordered pair really is on this graph. Okay, and you could do that with all 5 of them if you want to make sure. But let's go through and do this problem another way. All right, so here's where we're going to do it by, again, figuring out the period, which we already did in the previous one. That would be the 2 pi divided by 1/3, which is 2 pi times 3, or 6 pi. All right, so what we do is think about this. Now, in the regular sine chart, x sine x, remember these are the ordered pairs. We have 0, pi over 2 pi, 3 pi over 2, and 2 pi. And remember it goes 0, 1, 0, negative 1, 0. But how do things change when I have this right here? Well, what I need to do is think about how my x coordinates change first. Since the period is 6 pi, right, and there's no phase shift, so we're still going to start out with 0 something, but then I'm going to end up, my last thing needs to be 6 pi, not 2 pi, right? So remember what you could do is you could add a fourth of the period to get the next key order pair. So that is the same thing as adding 3 pi over 2. So we add 3 pi over 2, and then we add 3 pi over 2 again, which of course means you're just adding 3 pi to the numerator, 3 pi over 2 again, and 3 pi over 2 one more time. And I'm just writing them all with a common denominator, but you could of course simplify these. Now what happens with the y value? How does that get changed? Well, what are you doing with the y values for the sine? So if you know what the sine of, like, for 0 is, here you're doing negative 2 times that number and then adding 1. So to do negative 2 sine of x over 3 plus 1, we're doing negative 2 times 0 plus 1, negative 2 times 1, remember we're taking our y value over there, plus 1, negative 2 times 0 plus 1 again, negative 2 times negative 1 plus 1, and negative 2 times 0 plus 1. And these gives us these y values. 1, right, negative 2 plus 1 is a negative 1, 0 plus 1 is 1, 2 plus 1 is 3, 0 plus 1 is 1. So our ordered pairs are 0, 1, 3 pi over 2, negative 1. I'm going to write this as 3 pi, 3, I'm sorry, 3 pi 1, right? 9 pi over 2 was at 3, and 6 pi at 1. Are these the same ones we got before? All right, here's the values we got before, right? And here's the chart I just made up. I just copied and pasted over here, and we see they're exactly the same ones. So once you have these values, then you can go back and graph it, which is how we did it over here, a totally different way. You still are going to graph those same order pairs, and you get the same exact graph. So two different ways that you might do it. And of course, the other way is you just start plugging in a bunch of values for x until you get a smooth enough curve. That could take a long time. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.